All right, everybody. So what we're going to be looking at today is the product and the quotient rules. I'm going to move that over. Space. All right. Product and the quotient rules. So this should be a smaller lecture than the previous one, thankfully. What I will say, though, is keep in mind that when I was looking at the homework for the previous one, homework 14 had a quotient rule problem on there somehow. It should not have, but it did. So for homework 14, you do need to look at this a little bit. Also, for homework 14, they talked a little bit about tangent lines, and we have not computed any tangent lines, but we will in this lecture. So tangent lines are on homework 14 as well. So the point that I'm making is that we have a little bit of stuff that's not actually like supposed to be in this section, just because it didn't get covered in the previous lecture. Okay, so yeah, so that is how it is. So let's talk a little bit about tangent lines before we get into the product and quotient rule then. Okay, so tangent lines. Specifically, I mean, we've talked about tangent lines on a number of occasions now, and so you should have an idea of what that is, right? So I'm drawing one now. So we've got like some kind of curve. It doesn't matter what kind of curve. You've got some kind of point here, and there's a point on that curve, right? And we know what the tangent line looks like. Something like that. That might be a little bit off. We'll draw it a little better than that. Ooh, I want that point back. Oh, well, too late now. It's gone forever. So maybe more like this. Yeah, that looks a little bit better for the tangent line, right? It's supposed to have a slope of the line, and it's supposed to match the slope of the curve right there. So I think this does a little bit better. It's still not perfect. So this is the tangent line at a f of a, right? And so that should not be new information. You know what a tangent line is. But what we haven't done really is we haven't really been calculating the equation of tangent lines, okay? So here's an example of what you need to be able to do. So compute, we're going to say, let's see, suppose f of x equals, and I don't want to make this too complicated here, so I'm just going to say x squared plus 2x plus 1. That's going to be my curve, and I'm going to say find the equation of the tangent line to the curve at a point. What's the point? What is the point? 1 comma, whatever you get when you plug in a 1. So you plug in a 1 into this curve here. What am I going to get? 1 plus 2 plus 1. 1 plus 2 plus 1, is that 4? I feel like that's 4. So I'm going to say at 1 comma 4. So I'm going to tell you the point. Okay? Now, what you're supposed to do here is you're just supposed to think for a tangent line, or for any line, right? For a line, you need two things. I don't know why I'm saying a point, which we have, right? That's the 1, 4. And B, we need a slope. Now, how are we going to get the slope? Well, the slope of the tangent line is the derivative, right? That's the whole point of, well, not the whole point, but that's the whole point of doing derivatives, right? They're the slope of the tangent line. That's how we defined them. So a slope, we're going to get the slope by calculating f prime, and at a particular point, specifically this point, 1 comma 4, to get the slope there, we need to plug in a 1. All right? And then once you have your slope and your point, then we can write the equation. Then we can now use, typically we'll use this form of a line y minus y1 equals mx minus x1 as the way that gets to the equation of the line the fastest here. Okay, that's it. So this doesn't really involve you doing anything that you don't know how to do already, but it's just kind of putting the pieces together. So one thing I will say is let us look at this line here, y equals, what is it? X squared plus 2x plus 1. So you don't need to know what the graph looks like, but I don't like that. But you can, you can do with that. That's it looks like x plus 1 quantity squared, which means when you plug in a minus 1, you're going to get 0. So like if this is minus 1, go through there. If I plug in a 0, I get 1. So it goes through there, goes through there. All right, if I plug in a 1, what am I going to get? 4? They already said 4. I'm going to redraw that. Sorry. I want to draw it because I want it to fit. So I'm making it shorter here. All right. Okay. There we go. That's the curve. Now, you can get that graph from Desmos or anywhere if you want to know what that looks like. And we've got this point right here. The coordinates are 1, 4. And there's going to be a tangent line here. Which looks about like that. Okay, and so what we're looking for is the equation of that line. Now you do not need the picture in order to do this, but I'm just drawing the picture, so hopefully it makes sense. So we need, well, we have the point, right? So we need the slope. So this is where the work is. Okay, so we've got f of x, so find slope. Actually, hold on, let's write steps. Erase. All right, let's like write. What are you doing here? Please just erase. All right. So the steps could be written this way. Step 1, find the point, and step 2, find the slope, and then step 3, did I really just fail to spell step? We have reached a new low. Step 3 is going to be write the equation. Right, so basically a 3-step process. Of course, each step has its own pieces to do. So what's our equation? It was x squared plus 2x plus 1, right? So for step 1, we need the point. Well, guess what? There's no work because they gave it to us. All right, so that's fine. Step 2, find slope, right? And the slope at that point is f prime of 1. So you got to know that that's the slope. So we have f of x is x squared plus 2x plus 1, right? We have this. So what is f prime? F prime is the derivative. So this is just power rule. So the derivative of x squared is 2x. Then we have 2x. The derivative of 2x is 2. And then you have the 1, and the derivative of 1 is 0. So my derivative is just 2x plus 2. Now we need to evaluate this at 1. So you find f prime of 1. So you plug in the 1, and you get 2 times 1 plus 2, so you get 4. There's your slope. Okay, at this point, so we found this. So at this point, what we've got is a point and a slope. So the point that we're using is 1, 4, and the slope that we're using is 4. Okay, now the fact that we got 4 twice there, like 4 is the point and 4 is the slope, there is no reason why that should happen, okay? That's just for this particular example. How are we going to do this then? So you're going to write your equation. This is the point slope form, because we have a point and a slope. So y minus y1 equals mx minus x1. And you need to plug these all in the right place. So your slope is the m, right? And your 1, that's the x value, but it's not the x, it's the x1. Okay, the x we're going to leave as the variable x. And then your 4, that's going to be the y1. Again, it's y equals 4, but we're plugging it in for the y1. The y1 is the known point. Okay, so you plug those 3 numbers in those 3 places. So we've got y minus 4 for y1 equals m is 4, x minus x1 is 1. So we have this, and then we're just going to write it in the form that they want. They generally want like y equals mx plus b form, so we're just going to simplify a little bit. So multiply this out here, the 4 times the x and the 1. So you're going to get 4x minus 4. Then you add 4, and in this case, you just get y equals 4x. And that is your tangent line. Right? Just so happened that those canceled. Again, there's no reason for that. So this is your tangent line. All right. So easy peasy, but you got to go through the steps. All right. We're going to do one more. I'm going to say let f of x equal, I don't know, let's say 5x cubed minus 2x, right? And I want the equation of the tangent line at x equals, could be any number. I'm going to pick -2. All right. So it's going to be the same steps, but this time there's a little bit more work. So step 1, I need to find the point. And notice that this time I didn't give you the full point. I told you x equals -2. So we were given x equals -2. But what is the y value that goes with it? Right? You get it from the function. So you plug x equals -2 into the function, and that's how we're going to get it. Right? So we had half the point. We had the x equals -2, but we need the y value. So f of -2, right? F of -2 is going to be 5 minus 2 to the 3 minus 2 times, what was it, -2. So what is that? Well, I mean, it is whatever it is. You have to work it out. So -2 to the 3rd power is -8. -8 times 5 is -40. And then -2 times -2 is +4. So I think it is -36. Okay? So you do that, you find this point, or this value, and so your point is this. So the point that we're going to use is -2, -36. All right? That was what we were doing here. They gave us the x, we needed the y. Now, step 2 is we need the slope. Find the slope at the point. All right? Now, the slope of the tangent line involves the derivative. So we need the original function, which is somewhere, 5x cubed minus 2x. Okay? Now we need the derivative. So we're going to find the derivative. So power rule. So you bring the 3, right? We got the 3 here. You're going to bring it down in front. So you bring it down in front, you get 5 times 3x squared. Then you have the derivative of -2x, which is -2. Remember, you don't really need the power rule for a constant times x. So we're here, and that is 15x squared minus 2. That's my derivative. Now, I need the slope at the point. So we're going to have to plug in x equals -2, right? Again, that's the x value from our point into f prime to get our slope. So f prime of -2, right? Plugging in the -2 there, is going to be 15 -2 squared minus 2. So -2 squared is 4. 4 times 15 is 60. 60 minus 2 is 58. Okay, I was going to graph this for you, but I feel like this is going to be really tough to graph, but I'm still going to try when we get to that point. All right, so we got this. There's our slope. Okay, so at this point, I guess I'll keep going down here. Step 3, we need the equation of the tangent line. And so you have y minus y1 equals mx minus x1, and we need to plug in our information. So remember, the point that we were given, not given, we actually had to find, was -2 comma -36. And the slope that we found, we did have to find ourselves, was 58. And so if I highlight this with 3 different colors, right, I've got the point has an x value, the point has a y value, and then the point has a slope. So there's 3 things there. And where do those go? Well, the slope is the m. The y is actually the y1. And the x from our point is the x1. So you plug those where they go, and you get y minus y1, which is -36, equals m, which is 58. X minus x1, x1 is -2. So you see, you plug those all in to the right place, and then we simplify. So we got some signs to work out. So y minus -36 is y plus 36 equals, you have to distribute this 58. So 58x, and that's plus 2, right? X plus 2. What's 2 times 58? 116, I think that is. So I think that is plus 116. Then you would subtract 36 from both sides just to solve for the y, and you get y equals 58x plus 116 minus 36, which I believe is 80, right? You had 10, you get to 90, 20, you get to 100, 30, you get to 110, 6, you get to 116. So I think that's right. So this should be our answer. That should be our answer. Now, just to check, stop it. Why? That should be our answer for the tangent line. So what should happen is if I go to plot this, right? If I try to plot, let me write this down so I don't have to flip it. Sorry. That was a heavy metal pin falling on a glass, if you were curious about what just killed your eardrums. All right. So the curve was, it's somewhere there. 5x cubed minus 2x. The point is -2, -36. And the line was 58x plus 80. All right, let's try it. So let's come here, Desmos. And what we're hoping is that we can graph this. I'm going to have to change the scale to make it look pretty, so bear with me here. So we have, we want 5x cubed. So we want 5x cubed minus 2x. There's my curve. Now I want to plot the point just so we can see where it is. We want -2, comma, minus 36. Minus 36. 36. Okay. Now while we're doing this, let me just change the scale here. We will have projector mode, and this, let's go like -150. Man, it just doesn't want me to type in stuff. And then here, let's go +150. Okay, that's still not squished enough. Let's go here. -6, 6. Okay, so it took a little bit of work to make that fit. Notice the scale on the y-axis is like on the order of hundreds, right? That's because it's just a very tall graph. All right, now let me plot this tangent line. Y equals 58x plus 80. So do you see? You come here and you can see that the line goes through the point, right? -2, -36 is right here. It goes through that point, and the original curve, which is the red curve there, and the tangent line, which is the green curve there, match perfectly, right? They have the same slope and they go through the same point. That's what a tangent line does. And we did it. So we can be sure that we're right at this point. Okay, so those are the steps for finding a tangent line in detail. You have to do that maybe once or twice on homework 14. Not too much. A couple questions. Okay, so that's a tangent line. Now let's actually get in and do what we were supposed to be doing in this lecture. I said this lecture was going to be short, but not if it takes me 20 minutes to start. So power, nope, product, and quotient rules. All right. Now, the key to this is understanding that we did not give you a way to do products and quotients in the previous section, right? Sums are easy, right? If I want to do the derivative of f plus g, you should remember how that works, right? You just do the derivative of f. Actually, I don't want to write it that way. You do the derivative of f like that, and then you do the derivative of g like that, and then you just add them together, right? But that rule, like the equivalent rule, does not exist for products. The equivalent does not exist for products. What I mean by that is this. So if I do d dx of f times G, like this, it is absolutely not equal to F prime G prime. Okay? Not equal, okay? That's not a rule. And, you know, it'd be nice if it was. If it was, this would be a lot easier, but it isn't, okay? So you have to have a special rule for products and for quotients. So the one for products goes like this, and it's called the product rule, because it's the rule for products. Duh. All right, so we have the derivative of f of x, g of x. What is it equal to? So what it is equal to is f prime g plus f g prime. That is what it is. Okay, so the one up here is not a real rule, but this one right here is the real rule. Okay. Now I'm going to write the quotient rule here too, just so they're in the same place in your notes. But then we're going to go back to talking about the product rule first. Quotient rule. So the quotient rule is going to be for f over g, right? Which is a quotient. So what's the rule? This. It is f prime g minus f g prime over g squared. Okay, and that is the quotient rule. Just gonna box it in different color. Why, I don't know. Make the boxes the same size though. Okay, so there they are. That's the product rule and that's the quotient rule. Now, technically, if you want to use them, we should prove that they exist, okay? Now, what I'm not going to do is I'm not going to prove the quotient rule because the quotient rule is easiest to prove with the chain rule, which we'll learn later. I am going to prove the product rule, though. So, proof of the product rule. Now, I want to be clear about this proof of the product rule. You're not going to have to prove it yourself. This is just to convince you that it's true. Okay? So, if I want to do the derivative of f of x, g of x, then it is, by definition, the limit as h goes to 0. Remember I said you were done with this? Well, not quite. F of x plus h, g of x plus h, minus f of x, g of x, over h. That's from the definition of the derivative. All right? Now, what we have to do is somehow do something here. That's very instructive and informative, right? Do something here. Right. So basically what you have to do is add a term that's missing, but we need it. So the term that I'm going to add is going to be like a cross term, f of x plus h, g, and then, ooh, can I fit that? Okay, I need to just move this. Come on. Move it over like that. We'll have to delete that. We'll have to delete that. We'll delete all this. Okay. So what we're going to do is we're going to add this term, which was not here. But now it is. Is this what I want? I hope this is what I want. Oh, wait, but I can't. Hold on. Give me a second. Is that what I want? All right, I'm gonna hope for the best here. So what I'm hoping is that this is the right term. So what you do here is you're adding this term that is not here, but you think that it should be here because you're hoping that if you do some magic algebra, it'll just work out. And now that I'm looking at it, I don't think it is. Hold on a second. If I factored that out, I'll have g of x plus h plus g of x. No. Okay. No, that's fine. It's fine. It's fine. I'm sure it's fine. Let's keep going. So what I'm going to do with this is I'm going to kind of group the terms in a different way, actually. I want f of x plus h, g of x plus h, and then I want this second one here, right here. So I want minus f of x plus h, g of x. But then I have this one, which I'm going to write over here. So I should have just written it in that order, right? But then I was confused about what I was going to do, what I wanted. So I changed it. Okay. So we just switched those around. Now what we can do is split this up into two fractions here. Like this. In the first one, I'm going to take those first two terms and in the other one, I'm going to take the second two terms. I think it actually doesn't matter which way I did it, by the way, in terms of when I was deciding what I wanted to add and subtract. So I know that this is hard to read right here, but this term and this term are supposed to be the same. And this term and... No, that's not right. This term... Ugh. This term and this term are the same. Okay, so those two terms that are the same, if you can read my writing, which you can't, I'm going to take out. So I'm going to take out an f of x plus h, factored out, and I'm actually taking it out of the whole thing, and I'll be left with g of x plus h, and then minus g of x over h. So yeah, that's valid. And on the other one, I am going to take out a g of x. And if you take out the g of x, you'll be left with f of x plus h minus f of x. Okay? Now, the thing is that if we take the limit as h goes to 0, well, okay, I'm going to do a middle step here. So using the rules for limits, you can split this up into actually 4 limits. So like this limit is just the limit of the first part, right? This much. But then you also have the limit of this. But then you also have the limit of this. And then you also have the limit of this. So there's 4 limits here. So you can do limit as h goes to 0 of each one separately using the rules for limits. And I'm being super messy because I'm just hoping to try to get through this pretty fast. Okay, sorry. Now let's do each of those limits separately. So the limit of the first one, as h goes to 0 of f of x plus h, right? This limit right here. Well, if h goes to 0, that's just going to be f of x plus 0, which is f of x. Okay. Then the next one here, you should be able to look at that and just say, well, wait a second, isn't that just g prime? That should look like g prime of x. So it's g prime of x. Then you've got a plus. Then we've got a limit of here. What is that? You should recognize that as being f prime. And then finally, I'll use a different color here. You have the limit as h goes to 0 of g of x, but there is no h, so that's just g of x. Okay? And there you go. So we've got f of x, g prime, plus f prime of x, g of x. Now, if you compare this answer to what I wrote the power or the product rule was, it's the same. It's just I have it written with these two terms swapped when I wrote it. But that doesn't matter at all, right? Because you can change the order of addition and that doesn't matter. Okay, so that is a derivation of the product rule. And just to clarify this, so at this step up here where I added and subtracted the same term in the numerator, and then I sat there for a minute going, oh, well, wait, what was it? Do I want it f of x plus h or what? It would have worked either way. So I did f of x plus h g, but I could have done f of x g of x plus h and f of x g of x plus h. And then due to a temporary brain fart, I had both ideas at the same time and decided and couldn't decide which one I wanted to do. Thinking, oh, is it going to matter? No, it's not going to matter. So it would have worked out either way. So we just picked one. All right, so that's the derivation of the product rule. Okay, now what are we going to do with the product rule? Well, you're just going to be able to take the derivative of things that you would otherwise have more trouble with. So here's an example of using the product rule. Let f of x equal x squared plus 3x parentheses x cubed minus x to the fourth. All right? Now you have two options here. So option one is going to be multiply it out and take the derivative. That's what you would have to do if you were in the previous section. So here's what that would look like. So we want to do this. How would we do it? So what you would do is you would have to say, well, we could FOIL that. F of x is going to be, right, the x squared times the x cubed is x to the fifth. And then you've got the x squared and the x to the fourth is going to be minus x to the sixth. And then you've got the 3x and the x cubed. That's going to be plus 3x to the fourth. And then you've got the 3x and the x to the fourth, which is going to be minus 3x to the fifth. Right? That's what I get when I multiply it out, which is in order. Let's just write it in descending order. Negative x to the sixth. Then I've got like terms here for the x to the fifth and the 3x to the fifth. Is going to be minus 2x to the fifth and then plus 3x to the fourth. Is that right? Did I do that right? 5, 6, 4, 5. Okay, that looks right. Now that's not the derivative, okay? That's just the function. So you still have to take the derivative, and the derivative would be, now you apply the power rule. Negative 6x to the fifth, remember how it works? Bring the power down in front, subtract 1 from the power. Minus, bring the 5 down in front, you're going to get 10x, subtract 1 from the power, 4, 10x to the 4. Last one, bring the 4 down in front with the 3, you have 12x, subtract 1 from the power, so you're going to get 3. And that's going to be your answer. All right? But we have another option. Our other option would have been, that's not what I wanted. Our other option would have been product rule. All right? Now the product rule, why do I have, I don't know. Okay, I don't care. So the product rule, you would have done this. So we're going to have to do a little bit of erasing here. For the product rule, you have to think of like one of these as being your F. Oops, that's not how I wanted that to look. One of these is your F, and the other one is going to be your G. Now I know that the original function is actually called F, but I'm not paying attention to that because I'm like, I don't care about the name. I care about what it is, which is two things multiplied. And so I need the product rule. And so I know that the product rule as shorthand says FG prime is F prime G plus FG prime. That's the shorthand version of it, okay? With no of x's written in shorthand. Okay, so that's the rule. So for us, if I go f prime of x now, if I'm copying this form, I should have an f prime. So f is here. Again, the name is weird, but like f is that first one. So you take the first one, and then you just put a prime there. Okay, I'm gonna move this over a little bit. Then you need the G. The G is the second one, the green one. So you just write that. Okay, so there's my f prime G. And then I have plus f. F is the first one again. X squared plus 3x. And then G prime. G is the second one. X cubed minus x to the fourth, parentheses, and then prime. So do you see how I'm copying the form here? I've got like a prime on the F, and then I've got a prime on the, hold on a second, click over here. I got a prime on the F and then a prime on the G, and that corresponds to this one and this one. Now, then you just take your derivative. So f prime of x is, and then the two that have the primes, you still need to take the derivative of. So like the prime is on this. That's telling you take the derivative. So what's the derivative of x squared plus 3x? The derivative of x squared is 2x. The derivative of 3x is 3. So there's my derivative. The next term has no prime, so you just write it. The next term has no prime, so you just write it. The last term has a prime, so you take the derivative. So the derivative of x cubed is 3x, and the derivative of x to the fourth is 4x to the 3. So there you go. So there's your derivative. Now in this case you would still have to FOIL this. I'm very lazy, so I'm not going to. I'm just going to write it. But if you do FOIL this out, you would get the same exact answer. You must. Okay? So it doesn't matter how you do it, you'll get the same answer. Now you might be looking at this and just saying, well, I feel like this was less work, right? The left-hand half was less work than the right-hand half. But, I guess I should be negative. Maybe that's true on this example, but it's not true on every example. On some examples, the product rule will be less work. And on some, you have no choice. Okay? So just keep that in mind. Another thing is that they will ask you to do it in terms of numbers. So here's a problem from the homework. h of x is fg. F is negative 2x squared plus 2x plus 3. G is what? Negative x squared minus 3x minus 4. And what they want is, what is h prime of minus 1? Okay? And so the idea here is, like, by the product rule, I know what h prime of 1 is. H prime of 1, because h is just fg, so the product rule would say that is f prime of 1, g of 1, plus f of 1, g prime of 1. That's just writing out the product rule with a 1 plugged in. Okay? But I still need all these, right? There's 4 numbers that I need. So I need those 4 numbers, okay? Now, I can get 2 of them right away, right? Like, I can get f of 1. What's f of 1? Or it should have been, I should have been doing minus 1 this whole time. Minus 1, minus 1, minus 1, minus 1. What's f of minus 1? That's just plugging a minus 1 into the function that is given. So that's negative 2, negative 1 squared plus 2, negative 1 plus 3. That's a number. Work it out. So we have negative 2 times plus 1 minus 2 plus 3, which is, what do we got? Minus 2 plus 3. So minus 2 is minus 4, plus 3 is minus 1. Okay. Got one of the numbers. Another number is g of negative 1. So that's plugging a negative 1 into the second one. So that's negative 1 squared, it looks like, minus 3 times negative 1 minus 4. So that is minus 1 plus 3 minus 4. So what's that? Is that negative 2? I think that's negative 2. Right? So I got 2 of the numbers that I need here and here. Right? So one of them is going to go right here, and then one of them is going to go right here. But I don't have the f and the g prime. So I have to calculate those. So you have to say, well, we need to calculate f prime of negative 1 and g prime of negative 1. We need those. It's not that bad. We need to just know what f is. F is negative 2x squared plus 2x plus 3. All right, so that's f. So what is the derivative of f? Power rule, right? Bring the 2 down in front. You get negative 4x to the 1 plus 2, right? Derivative of 2x is 2. The derivative of 3 is 0. So that's it for my derivative. I need to plug in a 1, negative 1. So plug in a negative 1. I get negative 4, negative 1 plus 2. So what is that? Positive 4 plus 2. So it's 6. Now I've got one more number. I've got the number that goes there. So all I have left is g prime of negative 1. So let's calculate that. So g of x is negative x squared minus 3x minus 4. So g prime is the derivative, is negative 2x minus 3. We should be getting better at the power rule on these. Then I need g prime of negative 1. So you put a negative 1 and you get negative 2, negative 1 minus 3. So that's positive 2 minus 3. That's negative 1. So now I've got another number. Once you have all 4 of those numbers, we should just be able to plug those all in here. So I've got, So I've got h prime of, should be -1. -1 is f prime -1. Where's that? Here. 6. G of -1. That's here. -2 plus f of -1. That's here. And then g prime of -1. That's down here. -1. So what do I get? I get 6 times -2 is -12 plus 1. So -11 it looks like. -11. It's a number. Type that in, hit submit. Got it right. I'm a genius. All right. Oh, that's terrible. Okay. So let us talk a little bit about the quotient rule now, because we're already 50 minutes in. So let's look at the quotient rule. So the quotient rule, I said it was going to be short, but it's clearly I was wrong. Quotient rule. So let's write it down. So f over g prime. I'm not writing the of x because it gets in the way of seeing what it is. So f over g prime. It is f prime g minus f g prime over g squared. I wrote it in more detail up above, but here it is. Now that's only going to be, this is going to be if g is not 0, right? If g is 0, you're dividing by 0, and that's a problem. So maybe I should come up here and say that. If g of x not equal 0. Okay, so that's the rule. Now, this rule you can't avoid. Like I said, you can sometimes avoid the product rule just by simplifying before you use it. On the quotient rule, that's less likely. You can still do it, but only on specific ones. So here's an example. I'm going to say h of x just so I don't have to, so I can point to things and call them f and g basically. Let h of x equal 3x plus 1 over x cubed plus 3. All right, I'm going to say find h prime of x. Okay, now all you got to do is just think about this. The numerator is what we're going to call, the numerator is what you're going to call f. And the denominator is what you're going to call g for purposes of the product rule, right? As it's written right here, right? Top is f, bottom is g. Okay, now I know that the form of the product rule is f, I'm going to write it this way, prime g minus f g prime over g squared. That's the form. Put parentheses on everything. So all I've got to do is fill these in, right? I've just got to put, like, the f is here, and the f is here, and the g is here, and here, and here. So you just fill those all in the right place, and then we'll work them out. So it's not that bad. So f is 3x plus 1 with a prime. The g is x cubed plus 3, right? There's a g. Then minus f again, which is 3x plus 1 again. And then we got g, which is x cubed plus 3 prime, right? So two of the terms have a prime, that's it. And then in the bottom, that's another g, you've got g squared. So that's x cubed plus 3 parentheses squared. So another one. So there's an f, there's an f. Right, so do you see how that works? So you just basically fill in the blanks of your formula, and once your blanks are filled in, then you take the two smaller derivatives. So you've got basically here where you got to do a derivative, and you've got one over here where you have to do a derivative. And so you just do both of those derivatives and you are essentially done. You just gotta, simplify a little bit to make the answer pretty. All right, what's the derivative of 3x plus 1? Just 3, right? Remember, derivative of kx is k, derivative of a constant is 0. So that's just 3. X cubed plus 3. No derivative on that. Then we got minus 3x plus 1. No derivative on that, so we just leave it alone. Then we got x cubed plus 3 with a derivative on it. So what's the derivative of x cubed? 3x squared. What's the derivative of 3? 0, it's a constant. Then in the denominator, you've got this. What are we going to do? Nothing. Don't bother multiplying that out unless you got a reason to, which we do not. So just leave it the way it is in the denominator. In the numerator, we should still multiply this out. So you're going to want to take this basically and distribute that and distribute that, and be careful with that minus sign in the middle. So we would get 3x cubed plus 9, it looks like, for those first two terms, and then minus, and then when we distribute on the right, we're going to have 9x cubed plus 3x squared over x cubed plus 3 squared. Then in the numerator, I can see I got a 3x to the 3 minus 9x to the 3. So 3x to the 3 minus 9x to the 3 is negative 6x to the 3. Then I also have a minus 3x squared, right? Remember this minus here goes for both terms on the right. So I got minus 3x squared, and then I got this 9 here, so just like that. And I don't think there's anything I can do now, so I am now done. So that is my h prime, I believe I called it. All right, and that's the quotient rule. Let's do more. Whoa. Computer's really lagging. All right. Now, something I see that the computer's doing, and usually they won't do it, but it looks like they are, so we're stuck. So this is a kind of a more advanced product rule. How would you do a derivative like this? How would you do the derivative? Instead of an f and g, how would you do the derivative of f, g, h? 3 things multiplied this time. Okay? Now, I could prove this. It's easy. I don't want to because of time. I don't think you want me to either. But here's what happens. So basically, if there's 3 terms here, there's going to be 3 terms on the right. And what you do on each term is you take the derivative of 1 out of the 3. So like I could write f prime gh. So I wrote all 3, but I took the derivative of f. Then plus, I'm going to write all three again, F, G, H, but this time I'm going to take the derivative of G, and then I'm going to write all three again, F, G, H, and I'm going to take the derivative of H. So do you see how that works? Yeah, you see how that works, right? Now, why would you want that formula? Well, of course they're going to make you use it, right? They say like K is negative x squared plus 2x, 3x plus 2, x minus 1. And then they want find K prime, right? Now, remember what you could do. You could just multiply this all out, right? You could multiply out and then do the derivative. Maybe. Or use the product rule. And I would probably use the product rule here because the pattern is easy enough, right? So again, the pattern is you just take the derivative of one out of each three in each time you write it. And so if there's three of them, there's three in the answer. And if there's four of them, there's four in the answer, and so on. Okay, let's try K prime. So I'll write it out. So there's the first one with a prime. And then you just write the others. I already see this is in the way. Then you write them out again. Negative x squared plus 2x, 3x plus 2, x minus 1. Put the prime on the second one this time. Then you write them out a third time. Negative x squared plus 2x, 3x plus 2, x minus 1. And then you put the prime on the third one. So then you take the derivative on each one that has a prime. So this one needs a derivative, this one needs a derivative, and this one needs a derivative. And the ones that aren't highlighted, you just leave alone. So what's the derivative there of the first one? Negative 2x plus 2, right? And then 3x plus 2, x minus 1. Now on this one, you leave the first one alone. So x squared plus 2x. The middle one you take the derivative of. So what's the derivative of 3x plus 2? Just 3. Then x minus 1. Third one, you leave the first two alone. And you need the derivative of the last one. So what's the derivative of x minus 1? Just 1. Now, could you simplify this and multiply it all out? Yes. Do they expect you to? No, they actually don't. They expect you to leave it like this. Well, at least on some problems they do, and some problems they don't. You could multiply that all out if you want, but well, you know, it is what it is. So your choice. Let's see here. I want to see this. Now, they do give you sometimes some combined ones where you have, they say K is F G over H, where F is negative 4x, G is 2x minus 2, H is negative 3x squared plus 1, and then they want K prime. All right, now at some point you probably don't want to take the derivatives of f, g, and h separately and then try to put them together in the answer. It's probably best to write out what k is and just say, like, what is k? It's f g over h. And then from here, decide what's going to be the easiest way to take that derivative. Now, it's a quotient, so I need to do the quotient rule, right? But do I want to do the quotient rule the way it is, or do I want to do some simplifying first? And hopefully what you can see is that the top is really easy to multiply out, right? And since it is, multiplying out the numerator is going to be the easiest way to do this. Multiply. So we're not taking a derivative yet, we're just multiplying out the top. So if you multiply out the top, I'm going to get negative 8x, and then negative 8x squared, sorry. And then the negative 4x times negative 2 is going to be plus 8x. And then over negative 3x squared plus 1. So I would strongly recommend you do it that way. That way you don't need a product rule in the middle of your quotient rule. That's what you're trying to avoid. Okay? So there we go. Now from there, you've got a numerator, and you've got a denominator, right? So your numerator is what you're going to refer to as f for purposes of the quotient rule, and the bottom is g for purposes of the quotient rule. That's not what f and g originally are, but for purposes of quotient rule, right? And you know the quotient rule looks like this: f prime g minus f g prime over g squared. Okay, so you fill them in the right place. So k prime is, let me switch colors here, k prime is f prime. So f is just the numerator. F prime g minus, it's a minus for the quotient rule, f g prime over g squared. Okay, so you write out the quotient rule, and again, just like on all of these, once you write out the quotient rule, you just have a term with a prime that you need to do the derivative of, and another one with a prime that you need to do the derivative of. So we're going to get, what are we going to get? So the derivative of the first thing with a prime, negative 16x plus 8. Okay, power rule. Then negative 3x squared plus 1. No derivative there, so we just rewrite it. Next one, no derivative, so you just rewrite it. Last one, there's a derivative. So what's the derivative of negative 3x squared? It's negative 6x. What's the derivative of 1? 0. So that derivative is just negative 6x. Then in the denominator, you have this. Don't multiply out the denominator unless you got a reason to. Okay, that's important. It's just a waste of time, really. All right. So then, what would you do? Well, if you were gonna write this out, like, you should work out the numerator, which means like FOIL and then FOIL. So if I FOIL the numerator, I'm gonna get 48x cubed from the first two multiplied. The outer is going to be negative 16x. The inner is going to be negative 24x squared. And the last is going to be 8. Then for the others, there's no FOIL. We just distribute the 6. I'm talking about these two. Just distribute the negative 6x. So we're going to get 48x cubed, and then minus 48x squared. So we get that. We're going to keep going. So let's see what happens here. So I've got a 48x cubed, and then a minus 48x cubed. So those are going to be gone, right? I can see that. That's going to cancel. But for x squares, I have a, what do I have? I have a negative 24x squared, and then a 48x squared, and it's a minus 48x squared, which means plus 48. So minus 24x squared plus 48x squared. So that's a plus 24x squared. And then minus 16x plus 8, it looks like. Yeah. Like that. So this is how I would leave the answer. I would not multiply out the denominator, but if you wanted to, you could, but this is how I would leave it. Okay, and let me just move this over here. And this was called, stop. That was called K prime X in this problem. Okay, so that's, again, another quotient rule. Let's see here. Should we do more? Oh yeah, we haven't done any with just numbers. So let's do one with just numbers, and maybe that's it. Because it is hour and 11, so this is just as long as the previous one. All right, last problem. H of x is fg. And then they give me f is 2x squared plus 1. Oh, okay. And they give me numbers. They give me this, but then they give me g prime of 1 is minus 1, and g of 1 is 0. And then what they want is h prime of 1. This is weird, okay? Because look over here. They kind of mixed it up. They gave me numbers for g, but then they gave me a function for f. That is quite a strange thing. Let's see what that will do. So we want h prime of 1. So we have h of x is f of x, g of x. So of course, you now know what the product rule says about this. When you take the derivative, it's going to be f prime g plus f g prime. We want this at 1. So h prime of 1 is f prime of 1, g of 1, f of 1, g prime of 1, right? 1 is everywhere. Now you've got numbers here. You've got numbers up here for g prime and for g. So you actually have a number right here and a number right here. If you want to, go ahead and put those numbers in now. Why not? So f prime of 1, g of 1, g of 1 is just 0. Then you have f of 1, which we don't know yet. And then you have g prime of 1. G prime of 1 is negative 1. So the question is, what is f prime of 1 and what is f of 1? Okay, so we need to find these. And they're just numbers. We should be able to find them pretty easily, right? I'm going to find them off to the side here, if I can. So I have f of x, so right here, f of x is 2x squared plus 1. What is f prime? That's easy, right? Power rule. So what's the derivative of 2x squared? 4x. What's the derivative of 1? 0. So it's just 4x. Now I need f of 1, not f prime. What is f of 1? That's plugging a 1 into f. So that's going to be 2 times 1 squared plus 1. That's 2 plus 1, which is 3. All right. So I got a 3. I also need f prime 1. So f prime 1, that's using this formula, is going to be 4 times 1, which is 4, right? So I've got these two numbers now, a 3 and a 4, and just put those in the right place back in my answer here. So what do I have? I have f prime 1. That's 4 times 0. Plus f of 1, which is 3, f, and then a negative 1. So what's the result? It looks just like negative 3, isn't it? Just negative 3 because the 4 times 0 cancels. All right. So that's that done. So what did we do? We did a few problems with quotient rule. We did a few problems with the product rule. Hopefully you're getting better at the power rule. And yeah, so practice these. Doing this type of problem is really like one of the most important things you're going to be doing in this class, okay? So you need to practice this and get good at it. Don't cheat and do them all like on a computer or something. All right, that's it. It's an hour, 15 minutes. That's plenty. So let's stop here. Why won't it let me stop?